Okay, other objects in our solar system. And guys, I gotta tell you, I think I'm getting maybe a little too deep into this astronomy thing. It's starting to overtake me. I'm actually sort of becoming part of the solar system, man, part of the astronomy thing. I woke up this morning, man, my heart's a comet, right? I mean, boom, there it is. All right, so here we go. Other objects in our solar system, and I'll apologize if I show up one day late for school as like a supernova or something like that. I'll try not to though. All right, here we go. Satellites. Satellites are large objects that orbit planets. Okay, they can be a moon, they can be a planet, they can be a machine that orbits a planet or a star. So for example, the moon is a satellite of the Earth, and the Earth is a satellite of the sun. The moon orbits the Earth, and the Earth is the planet that orbits the star, orbits the sun. All right, the Oort cloud and the Kuiper belt. And that's a tough one to pronounce, man. It's actually pronounced Kuiper, kind of like viper with a K. All right, so the Oort cloud. Check this out. Looks a little bit like this. And the Kuiper belt. Looks a little bit like this. All right, the Oort cloud. This thing is crazy. So it was proposed. It was originally sort of thought that it existed in 1950 by a Dutch astronomer, Jan Oort. It may contain trillions of icy objects. Most of your long period comets come from the Oort cloud, and more on long period comets coming up. It's so far away though that not a whole lot is known about it. But we do know it's big. How big? Check this out. I'm going to go ahead and duck out of here. I'm going to go ahead and comet my way out of here. Check out this Oort cloud. Here we go. All right. Now, so if you look at it, this right here is the sun. And I know this is not a Kepler model because the planets are in perfect circles. So we're a little bit off here. So there is the sun with our solar system, okay? With our 8 planets, 9 if you want to play Pluto, with our 9 planets orbiting the sun. Okay, now this arrow right here is our solar system. Okay? And now, if you trace this yellow arrow from one end to the other, you will see what the Oort cloud is. The Oort cloud surrounds our entire solar system. So let's figure that out another way. So the Oort cloud, if you sort of think of like the solar system is the gooey center. So the Oort cloud surrounds the entire solar system. The solar system is in the middle of the Oort cloud. How crazy is that? The Oort cloud is huge, ginormous. All right, I'm back. So, dude, Oort cloud, seriously, huge, crazy big. Sort of wraps our solar system around it. Solar system in the middle, Oort cloud around the outside. All right, the Kuiper belt. The Kuiper belt is a belt of small objects, orbiting the sun just beyond Neptune. So it's a belt that is in our solar system, unlike the Oort belt or the Oort cloud that surrounds the solar system. The Kuiper belt is actually a belt that goes around the orbit around the sun, just past Neptune. It also contains trillions of objects. Most of our short period comets originate here. So tuck away that short period and long period comets. We're going to get to it. So here's a picture of the Kuiper belt. So you can see our inner planets, the gas, you can see our terrestrial planets on the inside, then you can see the gas giants just outside of that, and then we've got Neptune, and then we've got the Kuiper belt just outside of that. And again, this is where most of our short period comets originate from. All right, comets. Here we go. Love comets. So cool. All right, they're basically dirty snowball mixes whose orbits are with long, narrow ellipses. Now remember from the last time, you remember ellipses were just sort of oval. They weren't circular, like an elliptical orbit. All right, they're thought to be fragments and remnants from the beginning of the universe. There are two types of comets. Long and short period. All right, we're going to start with short period comets. They originate in the Kuiper belt. They have predictable orbits, meaning they're always pretty much in the same place, usually in the elliptical orbit around the sun. There's two families of short period comets. The first is the Jupiter family. And the way you can tell that they're a member of the Jupiter family is that they have an orbit of less than 20 years. So 20 years to go, or less, to go around the sun in one orbit. And the Halley family. The Halley family, short period comets, and they have an orbit between 20 and 200 years. So one of the famous ones about this one is the Halley's Comet, which just rolled through here. Well, I don't know. Seems like just yesterday, but I'm going with maybe 8 to 10 years ago. Might want to look that one up. So Halley is a very, very famous comet. Short period comets from the Kuiper belt. Long period comets. They're thought to originate in the Oort cloud, that ginormous thing that surrounds the solar system. These have erratic orbits. Because they're really, really far away, they don't have a whole lot of gravitational pull from other celestial bodies to give them a straight, more elliptical orbit. Like the sun does to us. Okay, so anywhere from 20 to tens of thousands, anywhere from 200 to tens of thousands of year orbits around the sun. Tens of thousands of years to make it around the sun. Sometimes they don't even orbit at all. Sometimes they just sort of shoot off. They may get accelerated by the gravitational pull of the sun. Just keep on shooting out into the universe, taking off on their own. All right, anatomy of a comet. So we have the tail, the hydrogen cloud, the nucleus, and the coma. All right, we'll start with the nucleus. A dusty snowball of rocks, ice, and frozen gases, as I've said before. So size, generally from 1 to 10 kilometers in distance. And so to give you a little bit of frame of reference, 10 kilometers is about 6.2 miles. All right, and I don't know, the proper pronunciation on this one, I think I'm going coma. The coma and the hydrogen cloud. It's a cloud of gases that surround the nucleus. So you've got that rocky sort of snowball thing, and then around that, you've got the coma and sometimes the hydrogen cloud. All right, so sometimes, like I said, sometimes the cloud of hydrogen surrounds the coma. This can be as big as 3 million kilometers in diameter. That's what I love about astronomy, man. Everything is so huge. All right, the tail. This is visible as the comet nears the sun. Tails can be very, very long. The longest observed tail was 475 million kilometers. So to put that in perspective, if the comet that produced this tail was Mercury, then that means the tail would extend past Jupiter. That's how long the tail on this comet was. All right, so what happens? The logistics is it melts some of the icy nucleus. Remember that little snowball? And then the light, as it gets closer to the sun, reflects the color off of the vapor coming off of the melting vapor off the nucleus. And the solar wind always pushes the vapor away. So if it's heading toward the sun, here we go. If the comet is heading toward the sun, the solar wind is blowing this direction. Okay, so it always pushes the debris, the vapor, the evaporating vapor, this way. Okay, so sun, wind, vapor, and that's why the tail usually points away from the sun. Cool little tidbit there. All right, asteroids. So asteroids are small chunks of rock orbiting a planet in space. So the size, from little tiny speck of dust to 940 kilometers. And they can be a little bit bigger. It's not exact. All right, most are found in the asteroid belt between Mars and Jupiter. So more on asteroids. They're thought to be chunks that formed the planets. So generally, these have more regular orbits than comets, and they kind of stay bunched together. They're just sort of like all these sort of big chunks of space rock all being pulled around the sun in a fairly regular orbit, and they generally stay in place. All right, so why are they there? Why do they end up being there? One theory is that Jupiter is so big that its gravity may have kept another planet from forming. So there's lots of extra chunks left over. So if you imagine the beginning of the universe as sort of like a great big lump of rocks, and the rocks sort of came together and eventually formed the planets that we have, Jupiter is so big that its gravitational pull disrupted those rocks' ability to come together and to form another planet. All right, meteoroids. A meteoroid is a chunk of rock or dust in space, and this comes from a comet or an asteroid, either one. So a meteor is a meteoroid that burns up in Earth's atmosphere, never makes it through. A meteorite is a meteoroid that hits the Earth's surface, and this can cause craters. So, speaking of some craters, here's some seriously cool stuff on a meteor crater in Arizona. And crew, at this point, I would just put down your pencils. This is a really, really neat thing. I'd love for you to just watch the video. No notes needed on this one, just tuck it away in your head. And I'm going to go ahead and comet my way out of here. And by the way, Sid, thanks for the idea. Out of here.
These are not the latest images from Mars. Did you know that located between Flagstaff and Winslow, Arizona is one of the best preserved meteor craters and certainly among the more famous on Earth? This is Meteor Crater, Arizona. About 50,000 years ago, a meteor of about 150 feet in diameter plunged into our atmosphere at speeds of up to 40,000 miles per hour. It would have taken the meteor 4 minutes to travel from New York to Los Angeles. Because of its speed, the friction of the atmosphere across the meteor would have made it the brightest thing in the sky. As it approached from the east, the desert plains of Arizona would have been lit up. In a blink of an eye, the meteorite struck the Earth with the force of about 20 million tons of TNT. The violence of the impact ejected over 175 million tons of limestone and sandstone over the surrounding plains. The resulting crater was 4,000 feet wide and about 750 feet deep. To put into perspective, 20 football fields can fit in the crater and about 2 million people can fill up the slopes. For more information about the crater, you can check out their website at www.meteorcrater.com.